What's up, heathens? How y'all doing? I'm the Godless engineer, and I critically analyze apologist claims to give you the best arguments and information so that you can stand up and use your voice. Today, we're taking a look at a clip from The Line. If you would like to, please go down below to the description and find a link to The Line and to the live stream that this video clip is coming from. If you enjoyed the video, please consider subscribing to The Line. I host over on The Line at least twice a month, so I hope to see you over there. Alright, let's get on into the clip. If you're ready to fuck around and find out what this crazy ass caller's talking about today, then please stay tuned. All right, let's get to the next theist caller, and that would be Denny. What's up, Denny? How you doing?
Hey, what's up, guys? How you been?
Doing okay.
Doing
How are you?
good.
Good, thanks for asking.
Tell us a little bit about your
So-
question, my friend.
Yeah, so I read a lot of books and I come to the conclusion that evolution cannot be true using evidence, observations, and archaeology as well. If I could
So
give
when
a
you- when
quick
you say-
example.
Shit.
Yeah, when you say evolution, what do you mean?
The gradual change over time that creatures experience.
Can creatures change at all over time?
Yeah, but gradually, that's the whole point of evolution. It's gradual change.
Not necessarily. That's gradualism, which is a certain tempo of evolution, but you also have punctuated equilibrium, which is a faster change that occurs in the face of rapid environmental change. It was outlined by, many different scientists over time, but it was popularized by Stephen Jay Gould in the 1970s and 1980s.
Okay, so you're saying it's not all gradual, okay?
Yeah, I'm saying that so evolution can occur at different paces because evolution and the change that a population of organisms may experience is limited by the environment that they are in, right? The natural environment that they have found themselves in, that they live in, is if it changes, it's going to see, you're typically going to see change in the population faster. If it stays the same, you might not see any change at all. You might see what's called stasis, which can occur in the fossil record and it can occur in real time. Right? This means that you're
Yeah, I
seeing
was going to talk
relatively
about
little.
stasis, yeah.
Yeah, that means you're seeing relatively little change in allelic frequency in the population over time. You're not seeing no change, but you're seeing very little change. So you can have stasis in a population, you can have gradual change, or you can have punctuated equilibrium in populations, which is, rapid bursts of change. Usually this occurs in places that are like highly seasonal or in the face of natural disasters like asteroid impacts or Siberian traps exploding, things of that nature. So when you see stasis in the fossil record, right, that usually indicates you're looking at a very stable environment. But if evolution couldn't happen, you would expect to see stasis and only stasis, not stasis some of the time, punctuated equilibrium other times, and gradualism other times still.
Okay. Yeah, I see what you're saying.
Denny, correct me if I'm wrong. I feel like what you're actually saying is that regardless of the tempo that evolution is taking place, that animals do not change, do not change via mutations or other mechanisms for change in populations. You don't. I feel like what you're saying is that evolution just doesn't take place. Is that correct?
Yeah, close to it. So fossils show like millions of years of small changes, like gradual small changes, but we see fossils and animals appearing suddenly out of nowhere. Even some very famous evolution biologists like Stephen Gould, they admit that it's extremely rare and the transition forms. So he sees it as a suspicion. So there's many
hold on, Denny. Sorry to interrupt. Sorry to interrupt, Denny.
Yeah.
But I feel like Erica just used Stephen Jay Gould, right? Mentioned Stephen Jay Gould for punctuated equilibrium, which is the thing that you're talking about right here. And this is a form, like a particular tempo of evolution. She just went through a really good explanation of explaining that. And now you're trying to use that in order to disprove evolution, which was not what Stephen Jay Gould was saying or trying to do or anything like that. And Erica has already explained how that is a factor of is already factored into like the evolutionary explanation for the diversity of life that we find today. So like, I feel like you just didn't listen to what Erica said. Would that be accurate? Like you either didn't comprehend or you didn't listen to what Erica just said.
I did. It's just different interpretations of his quotes. So I see it in one way.
No, it's not just different interpretations. And I feel like you're reading off of a script, and I get the feeling that maybe you don't exactly understand the script that you're reading.
Mm-hmm.
So to that point, then, right? So to that point, Stephen Jay Gould famously, he's like a super, super famous evolutionary biologist, right? Like, he didn't think that evolution wasn't something that happened. He proposed punctuated equilibrium as an alternative tempo to evolution and explicitly wrote against his quotes with regard to punctuated equilibrium being weaponized in conversations exactly like this. He wrote a formal piece, I believe, I can't remember which publication it was in. It was Nature Science, maybe Scientific American, one of those, where he wrote like a sort of op-ed, right, where he's like, I really would like it if people would stop misusing my argument for punctuated equilibrium as if it is an argument against evolution. And this is particularly the case because punctuated equilibrium was an argument that he made earlier in his career. And over the course of his career, countless transitional species were discovered, right? Basilosaurus hadn't been discovered yet. Sinornithosaurus hadn't been discovered yet. Many Australopiths hadn't been discovered yet. Many members of genus Homo were very poorly known. Pachycetus, Ambulocetus, many perissodactyls, countless tetrapods that link the gap between early lobe-finned fish and later land-dwelling fully fledged tetrapods, countless synapsids, countless proboscideans, countless saurinians, countless pinnipeds, countless carnivores of every stripe, right? Like, the fossil record has been filling out, and not just filling out, it's been filling out exponentially. It seems like every year we fill in these gaps more and more and more. And in fact, what that's caused people to do a lot of the time is to look back on some of the lineages that we've established as saying, okay, well, punctuated equilibrium was probably in play here. And it's caused people to look at these and say, actually, things were probably a little bit more gradual in this lineage than we'd previously thought. Punctuated equilibrium isn't as common as perhaps we thought because here are all these transitional forms showing morphologic change over geologic time in lineage after lineage after lineage, whether we're talking about land-dwelling artiodactyls becoming whales, water-bound tetrapods or lobe-finned fish, sarcopterygian fish, eventually becoming land-dwelling tetrapods, apes in the trees becoming bipedal apes on the ground that use tools, or reptile-looking synapsids becoming fully fledged mammals. Right? This is a tale as old as time with regard to paleontology. So I guess my question is, so I guess my question is, why do you find that stasis, in the light of all of that, and maybe you didn't know all of that, and if you didn't, I don't blame you, because evolution education in most places is not very good. So if you hadn't heard of all of those, then, I would encourage you to like go give them a look and see if you find them compelling and read into stasis and punctuated equilibrium and gradualism and see how these things sort of synthesize together to give us a better picture of how change happens over time with relation to the environment and with relation to social critters that influence each other in the cases of like sexual selection. But you also mentioned archaeology, and I'm curious as to what you feel from archaeology, what that has to do with evolution not being possible, because the screener has that mentioned. Would you be willing to elaborate on that a bit?
Yeah, I would. So artifacts like the London Hammer in 1912, I think, which is a rock which is formed like 11 million years. And this hammer is in the rock, which, again, cannot be explained fully and kind of debunks evolution, in my opinion, even more artifacts. But that's just one to begin with.
How?
Yeah, I think I know the London Hammer. The London Hammer is a classic. So, John, this is a classic. Like, it's a hammer found in rock that's supposed to be really old. So really nothing is actually as old as it seems. But the London Hammer isn't actually a paramineralized fossil because hammers aren't alive. So it can't paramineralize really, but it's also not a situation where it's behaving like a true fossil, because things don't become fossils, overnight. Typically, things can petrify relatively quickly, but the full thought process that gives us the types of fossils that you see in museums, like dinosaur bones or early tetrapod bones, or like those wonderful, beautiful fossils that you see entombed in stone, That kind of fossilization is not what we see in the London Hammer. In fact, it's not what we see in any of these proposed out-of-place artifacts. What we see in those cases is usually some kind of petrification that's the result of some kind of short-term process that we understand quite well in the present, because it's not dissimilar to the type of process that gets lime in your pipes, right? But getting lime in your pipes, or like petrifying a hammer, that doesn't involve the full replacement of the original material by leaching from the minerals surrounding it. So it's not the same kind of thing. Now, if you want to talk about, I get the feeling that you might be a young Earth creationist, like you might think that the Earth is like 6,000 to 10,000 years old. And if that's the case, then all I think I need to point to say that we know that that isn't true is that radiometric dating, which is the means by which we determine the age of rocks, and it relies on one law in physics called the radioactive decay law, which basically says that unstable elements are going to decay into stabler versions of themselves at a known rate. And that rate, we usually talk about it in terms of a half-life. But radiometric dating is used by virtually every single energy company in the world to find fossil fuels like coal and natural gas and gasoline and things of that nature that we use to power our economy, right? If this method didn't work, we wouldn't use it. Trillions and trillions and trillions of dollars wouldn't rely on this method to find seams of coal in the Carboniferous or in the Permian Basin in West Texas, and yet we use it. And we use it today. My brother-in-law was he did oil exploration out in the Permian Basin in West Texas for a while, and like that is what they do. And it is that process, radiometric dating, that tells us that the Earth is 4.5
to 4.1 billion. If I could say like one thing.
Yeah, sure. I was done. So sorry, I tend to ramble.
There's inconsistencies with the radiometric dating. So, for example, the rocks in Mount Helen, if you're aware, which they, I think,
no. I'm gonna stop you right there. Hold on, Denny. I'm gonna stop you right there. I'm fairly certain that Eric has heard this before. I've heard this before. The whole Mount St. Helens thing, and sure, you can send off rocks that were produced by a volcano or anything like that off to any place and have them do radiocarbon dating or anything like that, and they'll come back with different kind of time frames. But I always like to make this analogy that you can open up a car door with a hammer, but that doesn't mean that you should. And this is analogous because you can misuse radiometric dating and get whatever dates that you want to. And you think that it proves something about radiometric dating. I can't remember all the exact specifics about the lab results that were, or the lab tests that were done on the Mount St. Helens rocks. But from what I remember, they used the wrong kind of radiometric dating method on it, and they also were too young to actually radiometrically date. There's a certain time frame in which it can date, and rocks that were formed by Mount St. Helens exploding is not going to be within that range that they can date it. So, like, for instance, with volcano flows, what you're looking at is, I believe, potassium-argon dating, if I'm not mistaken. And the reason why you use potassium-argon dating is that as the lava flows from the volcano, it's going to consume vegetation. When it consumes vegetation, what you're going to have are these potassium isotopes that are going to be encased in the lava flow. And the reason why this is important is because the argon is, I believe that's a noble gas, if I'm not mistaken. It's a gas. And so when the lava, consumes the vegetation, and this potassium isotope is contained in these this plant life, there's not going to be any argon that's present in there. So, like, when you start off dating this lava flow rock, like when it forms, no argon. So any argon that you actually find in this lava flow rock sample is going to be produced because of radioactive decay. Now, because radioactive decay is like clockwork, like it's one of the most stable things in the universe, we can use it as like a timer, like a clock. And so we can date that by measuring the amount of potassium that's there versus the amount of argon that's there. And so, like, if you use radiocarbon dating on rock that was formed from a volcano 20 years ago, you're going to get really inconsistent results. but that's because you're using the wrong kind of dating method, and you're also dating rock that can't be dated by those methods.
So if I may, I actually, this is my bread and butter, if you will. I know that Mount St. Helens example, I know the New Zealand example, I know the Australian examples, I know the Hawaiian examples. If there's an example of incorrect radiometric dating, I've probably seen it. And what John said there about not being able to date rock that's too young is wholly correct, right? The way that I like to think about it is like this. If you have a semi-truck and you want to measure that semi-truck, right, or a boulder that weighs 100 tons, you're not going to put it on a microgram scale or the type of scale that you have in your house to measure yourself, because it's so much weight that it's going to break the scale. And if it doesn't break the scale is going to return noise because it can't possibly measure something that is hundreds of tons. It's just not going to be able to do it. Such is the nature of radiometric dating. If the entirety of the sample is all parent material, it breaks. All you're going to get is noise in return, because the mass spectrometer usually is what's being used. It's looking for daughter material that isn't there. So you can't radiometrically date rock that's too young. There's just no daughter to measure. So that, I think, in creationist tends to get a response that's like, well, that's awfully convenient. It's awfully convenient that we can't measure anything that we know the date for, like recent volcanic eruptions. But we actually can do that. And this is one of my favorite examples of radiometric dating working like a charm and proving my point that I'm making right now precisely. So all of the examples that you've read, Denny, I challenge you to go and look at them and see when these volcanic eruptions happen. I guarantee you, I bet my hat that all of them are less than 1,000 years ago, because the range to start getting a little bit of daughter material that you can actually read for methods that are precise, like argon-argon dating, which relies on 2 isotopes of argon, is a couple thousand years. You need a few thousand years for enough of that parent to decay into daughter to actually get some kind of reading, which is why those couple 100-year-old volcanic eruptions never work. You're never going to get an accurate date for those. It's just too much parent material. So let's look at a volcanic eruption that we know happened, that we have a guaranteed date for, like Mount Vesuvius. Mount Vesuvius erupted a couple of, maybe, I think it's like 70-something AD. I think it's 71 AD, 71, 79 AD. Basically over 2,000, approximately 2,000 years ago, let's say. That's a date that we know because historians wrote it down. I think it's Pliny the Younger. It's one of the Plinies. Pliny the Younger or Pliny the Elder was basically like nearby. They knew that Pompeii and Herculaneum were these locations that existed. They go to visit them. These places are gone, and Mount Vesuvius is half the size that it used to be, because when Mount Vesuvius erupted, it blew its top, and you got these massive pyroclastic flows down the sides of the mountain that completely did these cities away. In some cases, the heat was so intense that it turned the brains of the individuals into glass. That's the kind of heat that we're talking about here. But like John said earlier, what pyroclastic flows have in them is igneous rock, which is the type of rock that you radiometrically date. Now, fortunately, you don't actually need vegetation to radiometrically date using potassium argon. You do need that for radiocarbon dating because it relies on the nitrogen and carbon 14 relationships. But so what scientists did in this wonderful, like 2002-ish paper, I think it was, no, actually, I think it was 2010, a 2010 paper, is they went to Pompeii and they took samples. They said, we know the calendar year that this thing erupted. Let's radiometrically date it. Because if radiometric dating works the way I'm telling you it works, which means you need a couple thousand years for just enough daughter to decay to actually detect it, this is your example. This is the creationist example that they've been begging for. A volcanic eruption that occurred at a known date, which has rock that we can actually radiometrically date on it, that has had enough time for daughter material to decay to give us an actual date instead of noise. So what did they do? They argon dated it, and they got the calendar year of the eruption using radiometric dating on this thing. It's a phenomenal paper. Now, that kind of thing shouldn't happen if radiometric dating worked. And furthermore, every time that radiometric dating doesn't work, it shouldn't fit the exact situation that I've presented to you, which is dating rock that's too young, or that John presented to you, which is dating rock using the wrong kind of method, like, for instance, trying to carbon date rock. that's not going to work because carbon and nitrogen are not typically found in igneous rocks. You have to have a method that actually works. And moreover, and I feel like this point wasn't appreciated the first time I said it, you shouldn't be able to use radiometric dating to underscore the entirety of the world's energy economy. None of those things should be true, and yet all of them are.
Okay, I see what you're saying. Very good examples you gave. You're saying like if you use the wrong measurement, like if you open a door with a hammer or the scale example you gave, you cannot measure it. So isn't the whole point of of the dating, isn't the whole point of it like to be accurate? So if we have examples of it being non-accurate,
I'm sorry, Denny.
Yeah.
No. Hold on. I need to stop you because I feel like you're not listening to what we're saying. We're saying when used appropriately, maybe I need to repeat that part. When used appropriately, you get the correct date. And that's the entire Mount Vesuvius example that Erica just gave. So it seems to me like in this conversation, you have just simply not listened to a goddamn thing we've said.
Yeah, I listened actually to everything you said. And she said very good examples and good points. It's just the amount of evidence I have seen like clearly shows inaccurate fossil dates.
Denny, I'm sorry. No, listen, Denny, I'm so sorry for interrupting you. You cannot sit there and say that you've actually absorbed this information, you've understood this information, or that you were listening when we gave you the responses that we gave you, and then you come back and you're like, yeah, but aren't these methods supposed to be accurate? In no world does it make sense that you grasped what we talked about and then you had that as a follow-up comment.
It's kind of like this, Denny, if I may, right? Like if I have viral pneumonia, right, and I take antibiotics, the antibiotics are not going to cure my pneumonia because antibiotics are for bacterial infections. The same is true with radiometric dating, right? If you're trying to apply radiometric dating to a sample that has no daughter material, you're going to get noise. It's why these incorrect dates that creationists get are all across the map. There's no rhyme or reason to them because they're trying to read noise. That's what happens. But we know antibiotics work on bacterial infections, and in the same way, we know that radiometric dating works when it is used the way it's supposed to be used, right? You can't take a method. Yeah, you can't take a method that has known limitations, like limitations that are known and appreciated by people who are in that field, and then use it with like outside of the constraints of those limitations, or rather within the constraints of those limitations, and then expect it to work. But that's what creationists do a lot. I've found with this is they'll say, "Oh, see, we've tested radiometric dating and it just doesn't work." And it's like, "Okay, well, what did you use it on?" And they're like, "Well, we used it on rock that's too young." And it's like, "Okay, well, have you tried it on rock that's old enough?" Because that would really make their case. But Denny, they won't do it. They won't actually.
Yeah, they only do it on young one. Okay, I see. Yeah. So to me, if you're a creationist and you want to make your point here, you could do this easily. Get rock that's old enough to be radiometrically dated from a place like Pompeii, where there's a historical date for it, and run it. And if it's incorrect, then maybe there would be a point there. Maybe they would have a point. Maybe there's another explanation, but maybe they would have a point. But they won't do it. And I know this because I read I read Radioisotopes in the Age of the Earth, their best attempt out of ICR to try to prove that this wasn't something that had happened. Oh.
But instead what they did is at the end of a 5-year campaign by the Institute for Creation Research, where they tried to disprove radiometric dating, when they finished that project in 2001, and then they had a secondary project after that, which they finished a couple of years later, they said, okay, we admit it. When we look at these rocks, it does look like a lot of radioactive decay has happened. In fact, it looks like about a couple of billion years worth of radioactive decay has happened. So what they changed the argument to, at least here in the United States, is that really and truly all that radioactive decay did happen. It just happened really, 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 really fast. And it happened during the year-long event of Noah's flood. Okay, that's another story that we could address, and we could talk about why that doesn't work as an explanation. But first, we have to appreciate the fact that they had to admit that when you look at all of these rocks, they all look old. None of them look young. None of them look as young as they should be. And I think that's a real problem for them.
Yeah, so you're saying like when it's used the proper way, when you don't use it on recent rocks, but on very old ones, like then it's the proper way, so it's gonna work. So can you clarify the difference between within geometric dating and carbon-14 dating?
Yeah, it doesn't even have to be really old rock, though, Denny. It just has to be old enough. It doesn't have to be millions of years old. You just have to have something
old
that,
enough,
you have to have a sample where enough daughter has decayed. Pompeii was 2,000 years ago, right? Like that's not that old. So, but they never do that. They always pick volcanic eruptions that happened like 50 years ago, or like 100 years ago, or like 200 years ago. They never pick appropriate rock, and I think that's because they know it's going to be accurate. But that's just me.
Yeah, and so to answer your question there, Denny, about the difference between carbon-14 dating and radiometric dating, carbon-14 dating is radiometric.
Just to clarify the question, is carbon-14 dating used on millions of years old, or just like recently? What's the way it's being used?
Carbon-14 dating is only used on stuff that's under 60,000 years.
Yeah.
50,000 or 60,000, yeah?
Yeah,
on organic materials, I think.
60, 60,000.
Okay. So why did they use them on the dinosaurs? Like they use them on carbon dating.
No. Well, so you would need to. I feel like you're a little misinformed on which dinosaurs that it would be used on. Because most of the time when you're talking about very old dinosaurs, you're talking about using different elements. So there would be different forms of radiometric dating that are used, like the argon to argon dating that Erica was mentioning. There's potassium argon dating. There's also lead. What is it called? It's lead something.
Uranium
dating.
lead. That's the uranium lead
dating. Yeah. And so, for instance, if you wanted to date a layer that fossils appear in, what you can do is you can actually get zircon crystals, and you can date those. And if they happen to be in the layer, you can get those, and you can date them by one of the various methods. I think normally zircon crystals are actually tested with lead uranium dating, and that's because the crystalline structure of the zircon crystals, they're accepting of lead, but they do not accept the uranium, or I get those mixed up on occasion. I don't. It's one of the two that the crystalline structure will accept that inside of its structure, but it does not accept the other. So when the zircon crystals form, there is no daughter element that's present. So whenever you test the zircon crystal, if there's any daughter element present, it can only be because the parent element decayed into the daughter, and then you can measure that time. And the reason why you would use uranium lead is because uranium lead, it's on the order of millions of years, if not billions, I think.
Billions.
Yeah, billions. It'll give you pretty accurate dates. Now, as far as accurate dates goes, there is like a margin of error on either side of it. So like when you're talking about something that old, you're going to get like, a margin of error of like millions of years. But you're very obviously dating something very old. So that's why that margin of error seems big, but it's not big in comparison to the entire range that it can be used to date. So you'd have to be a bit more clear. Sorry, Erica. You'd have to be a bit more clear which dinosaur fossils you're talking about are being radiometrically dated, because considering the limitations of radiocarbon dated, the limitations of radiocarbon dating, you would definitely need to specify which fossil you're talking about, and then also we could explain why you're probably misusing the method. Sorry, go ahead.
Yeah, if you want to go into a specific case involving like dinosaur bones, I think it was in Montana, the Hell Creek Foundation or formation. It was believed to be millions of years old using carbon dating, and it suggests that it's inaccurate use just because the material was found and they used it. And it suggests that only a few thousands of years old, which is like misleading. And it's like inappropriate use of carbon dating. Yeah.
Jenny, so I know this example. I was nodding earlier because I was like, I know exactly where this is going. This is going to be a sort of Kevin Anderson style, or Mark Armitage style, I guess I should say, rather, situation where it's like you have a bunch of creationists who are like, I bet if we carbon date dinosaur bone, which conventional science says you can't carbon date because it's too old, we're actually going to get carbon, and that's going to prove that the Earth is very young because there shouldn't be any carbon left. And therefore, if we find carbon, that means that it's way younger than 65 million years for something like an Edmontosaur or for a T-Rex. That's how the argument classically goes. Now, the problem with this is carbon dating is one of the few radiometric dating techniques for which contamination is rampant and easy. And the reason for this is that carbon is everywhere. You can get carbon reintroduced into a system by cosmic rays. Literally just sitting in the sun can reintroduce very, very small amounts of carbon into the system. You can get carbon in the system by water percolating over the bone. So if the bone is exposed and it rains on the bone, you can reintroduce carbon that way. Or if it's in a crack where it's exposed to any amount of groundwater, you can reintroduce carbon that way. So this sets up a really, really nice prediction, because if the limits of carbon dating are about 60,000 years, then reintroduced carbon, which is always going to be in very little amounts, are going to result in erroneous but very old carbon dates. So what I'm saying is that if I have a dinosaur bone, and the dinosaur bone was actually from a dinosaur 6,000 years ago, the amount of carbon in that dinosaur bone is going to correspond to 6,000 years, give or take. What it's not going to correspond to is 60,000 years, or 70,000 years, or 50,000 years. If you get that latter signal, what that is telling you isn't that the dinosaur bone is 50, 60, or 70,000 years, but it's telling you that contamination is a pretty possible, and in fact, almost certain, given it's a dinosaur bone, reason for the minute amounts of carbon still in the system. So creationists need the amount of carbon in all these dinosaur bones that they date to be 6,000, 7,000 years. And what we actually find when we carbon date things that are not supposed to be carbon dated is the scantest, tiniest, littlest, ittiest bittiest amount of carbon still in the system, which is due to a process that we understand extremely well because we have tested it before in laboratories. So yes, when you carbon date a dinosaur bone, you might actually get a small amount of carbon in it, but it is never going to correspond to the dates that creationists need it to correspond to. And in fact, the signal that it gives is always going to be the signal of minute amounts of reintroduced carbon. And the way that I know that is because I always check. When creationists tell me that they radiocarbon dated something and they got some date that they shouldn't, the first thing that I do is I go and say, okay, how old did the carbon dating say it was? Because if the carbon dating is saying that it's really, 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 really old, the maximum amount that carbon dating can say something is, what that means is that if it really was actually that old, so much of that nitrogen has decayed into carbon that's why that tiny amount is being shown as present. It's basically saying there's barely any left by conventional means, which is the same signal that you get from reintroduced carbon. You're never going to reintroduce carbon your way back to a 6,000-year-old date. So I would urge you, Danny,
I agree, yeah.
I would urge you to check those sources and see what they say. Sorry, that's it.
Sorry, I'm going to let you go here, or not let you go, but let you continue there, Denny, here in a second. But I did just do a quick Google search, which is something that you can do. I'm assuming that you can use Google for the Montana shale radiometric dating. That's correct, right? That we're talking about.
Yeah.
And it says it says that uranium, lead, potassium, argon to argon, and also rhenium and osmium dating is used to date that formation, and none of those are radiocarbon dating.
So you're saying it's not? Oh, just because I've read differently.
Right, from the Institute of Creation Research or maybe Creation Museum. I mean, you've heard from creationists these things, and I think that maybe you need to step outside of the ICR, AIG bubble and actually look at real, like, scientific studies on this. Because, like, the first things that come up on a basic Google search on this, if you were to double check like what the creationists are telling you, geoscience world, I mean, hell, Wikipedia would probably be fine National Center for Science Education, USGS Publications, Science Direct. These are all legitimate scientific journals and scientific websites that are going to give you good information. Don't go, like, when you're looking at like this kind of stuff, if you read something from creation.org or whatever in the fuck, definitely just go and Google it, because these are basic things that can be Googled and will come up immediately.
Denny, a lot of these.
I see it's not. Yeah.
I'm sorry. I interrupted you. You continue.
Yeah. You said before, like, if it's like 6,000-year-old like bone or skeleton of a dinosaur, you could determine that using carbon dating. It's gonna show exactly 6,000. But if it's above 50,000, it's not gonna be accurate. So there's no point in using it. And yeah, so the other host provided a well argument. It's actually carbon dating was not used, and that's my mistake. Probably radiometric dating was used. Yeah.
So, but you're not incorrect, though, Denny, that creationists have tried to radiometrically date dinosaur bones, and what ends up happening is the situation I've described. So if, I'm assuming that you read that they radiometrically dated a dinosaur, or radiocarbon dated, a dinosaur bone somewhere. So my challenge to you is to go and see what number they got. Right? Because the whole point that creationists are trying to make is that the dinosaur bone is way younger than the evolutionists are telling you that it is. And that's why it's giving a young radiocarbon date. If there's another side of that coin, right? Which is that if the dinosaur bone is 6,000 years old, which is usually what they're trying to say that it is, or 4,400 years ago, if it's after Noah's flood, then that's what the carbon method should say that it is. The radiocarbon dating method works on things that are a few thousand years old. You can actually use it on things that are a few hundred years old. It has a much younger range than most of the radiometric dating methods like argon or uranium lead or rhenium osmium or whatever, right? And in fact, we use it in archaeology a lot, right? Like, we use radiocarbon dating to date papyrus mats in Egyptian mastabas or whatever. Like, it works for that kind of thing, which means that if the creationists are correct, those dinosaur bones, if they're really 6,000 years old, they shouldn't be showing us the same pattern that you get when carbon is reintroduced, a phenomenon which we understand quite well. It should be telling us that those dinosaur bones are actually 6,000 years old, but it isn't. At least not in any case that I've ever seen. If you have a source for a dinosaur bone that was radiocarbon dated to being 6,000 years old, I'm very interested in seeing that, because I've never seen anything produced by them of that nature.
Yeah, I'll definitely look at what you said to look like. I think it was 65 million of years old. It was determined about this case in Montana, but if I could just quickly say, like, other examples, like the horseshoe crab, which is 450 millions of years, it shows no evolution even to today. Like, many examples show the same bone structure, skeletal structure, and everything, which is quite fascinating, and I cannot explain it. Maybe you can.
Denny,
the dragonfly and so on and so on. Jellyfish.
So I get that we've been on this call for a while. It's 30 minutes. At around minute 5, between minutes 5 and 10. Erica provided a detailed explanation for stasis occurring and explained why it would happen. Yeah, and why it does not pose a problem for evolution. There are many reasons for stasis happening, which is the thing that you just now described. I'm sorry, but this is the third or fourth time in this one call that you have repeated things that we have already discussed with you, and as if we haven't discussed it with you. Do you at least recognize that we've already discussed that point?
She said a lot of things, and I didn't hear all the things, but she said many things, and maybe I forgot some of them. She just went over many topics, many examples, and probably that's why.
Okay, do you understand what stasis is?
Yes.
Do you understand that stasis does not pose a problem for evolution?
Not quite, but that's just my view. It's okay.
So Denny, let's that's actually something we can explain. So I'm going to give it, we're doing a little bit good cop bad cop thing. I'll give it a quick go. So evolution happens, right? That's the change in the allelic frequency of a population over time. And if that happens for long enough, it results in macroscopic change and speciation and things getting antlers or wings or changing body plans or whatever, right? Macroscopic change, this so-called macroevolution, which is just microevolution, but over a longer time scale. The way that evolution occurs, the way that those changes happen, is via the mechanisms of evolution. The two primary ones of which that we tend to talk about and sort of introduce the concept with is mutation, which is what introduces variation into a population. And that just happens because there are errors when cells try to divide, right? There's errors in DNA replication and protein synthesis. That gives variation to populations. And then natural selection, or really, I guess more accurately understood, natural filtration, right, will select organisms which are better fit for their environment, in that they will be better at reproducing than their peers. That's all that's happening in evolution, is that you have variation in a population, and in that population, in a given environment, some critters are going to be better than other critters at reproducing. And when they reproduce, they pass those beneficial genes that allowed them to be better at reproducing onto their offspring, and that happens for generation after generation, and then the population will change over time. What that relies on is that the environment is changing in such a way so as to give an edge to some individuals over others. But if the environment doesn't change very much, the population's not going to change very much either, right? Because if the environmental changes are the things that are driving that differential reproductive success, meaning some individuals are better than others, right? Let's say I have a population of foxes with medium length fur and it starts to get colder, and there's natural variation in my fox population so that some have slightly longer fur than others. Because it's getting colder, the foxes with longer fur are going to have an edge, right? They're going to stay warmer. They're going to reproduce more often because they're going to live longer and eat more food because they're not going to be cold all the time. And then they're going to pass those genes for long fur onto their kids. And if it keeps getting colder and keeps getting colder, then the longer furred foxes are eventually going to be the only version of foxes within that population. But if that environment isn't changing, then you're not typically going to see populations drastically change in any direction. You're going to see stasis. They're going to stay the same. Another word for this, as far as like the type of selection, is called stabilizing selection, which is doing exactly what it sounds like. It's stabilizing the population to stay the same because the version that they are right now is pretty well suited for the environment that they live in. Now, when I think of environments that are pretty stable, really one environment comes to mind, and it's the ocean, right? Because changing the chemistry of the ocean is pretty tough, and the ocean isn't typically subject to the same weather patterns that the land is. So we tend to see stasis happen most frequently in aquatic animals like horseshoe crabs or like, coelacanths, right? So does that explain, at least from an evolutionary perspective, what stasis is and why it happens to some populations and not others?
I would say a perfect definition of stasis, you just gave examples of. And
Okay,
if I could say, you explain how stasis works and everything. It's just not like 10,000, it's not 100,000, it's 500 millions of years of stasis, which is a big number, and I cannot comprehend. Many people, creationists, they cannot comprehend these numbers because it's impossible in our view. But
Denny, the problem is those horseshoe crabs and those lungfish, or sometimes they point to coelacanths in the Devonian, talking about 500 million years or talking about 300 million years or whatever. And I really can't stress this enough. They haven't stayed identical. Stasis doesn't mean identical. It just means the population is stable. So the change that's happening isn't extreme. But when you compare a horseshoe crab from today to a horseshoe crab 550 million years ago, or rather 500 million years ago, they look pretty different. The carapace shape is different. The way that the body shape is segmented out is different, with emphasis on different segments. Aspects of the tails and the legs and the eyes are different. So it's not that horseshoe crabs haven't changed at all, right? They have changed quite a bit. It's just more or less horseshoe crabs have been a very successful taxon, and they were around then and they're around now, right? I could point to worms and say the same thing. We've had different types of flatworms for 550 million years. We've had different types of arthropods for 550 million years, right? We've had sharks since the Ordovician. We've had tetrapods since the Devonian. But just because something is still around doesn't change the fact that there are innumerable millions, billions of species that aren't around still, that have either evolved out of that species, descended from that species, right? Or they've gone extinct. So I think from the creationist perspective, it's a little tough because from an evolutionary perspective, we can explain stasis and we can explain evolution, right? We can explain why critters stay the same and we can explain why critters change. But from a creationist perspective, you have to hope that things don't change at all. Otherwise, you're kind of up a creek. You can't explain these vast changes that we do see in the fossil record. And that goes for things like horseshoe crabs and coelacanths too.
Erica?
Yes.
I've appreciated this learning moment, like in this call, like that I'm getting from you, right? But I feel like our interlocutor does not feel the same way, because it's a little hard to convince me that he is taking this in or paying attention at all when he's consistently commenting.
I know.
You're talking. Yeah.
Yeah, she just said there's billions of examples of evolution. There's examples of stasis.
Denny, shut the fuck up. That's pretty fucking rude, right? Like, if you're going to ask, no, you've asked an expert in this field to explain these things to you, to rebut the things that you're talking about, and then as soon as she starts talking, you go typing away on your goddamn phone into the chat, spewing your fucking preaching bullshit that I saw? Like,
that's my brother. I'm on the call, yeah.
What?
That's my brother next to me. He's in the chat. Yeah, he's typing from my account. Yeah.
Oh, okay. Well, why did it say this is Denny from the phone call? Like earlier in the thing before he got like booted out,
that's my personal account. Denny. You can see, yeah.
Okay, so your brother's a fucking liar then? He was claiming to be you when not really you then.
Banned from chat.
Is that right?
It's me. He's with me. Yeah.
Okay, so you're doubly not listening to Erica hand you your ass, and you're dictating what should be.
I'm actually taking notes of Erica.
Oh, are you? But it doesn't. If you're taking notes, you're the shittiest note taker ever, because like we've had to reiterate things like 3 or 4 times in this one fucking phone call. So if you're
just
taking notes, you're not taking
doesn't
notes
mean I asked. Yeah.
Okay, Denny, appreciate you calling in. I'm really fucking done with this conversation. Yeah.
Don't swear.
Bye, Denny.
Thank you. Yeah. Don't swear.
Denny, take some time to, I know he's gone, but take some time to look over the notes, call back, check into everything that I've said. Listen, John knows this about me. I could go eternities with creation. I could just go back and forth. I love it. I think it's the most fun thing in the world. And, probably he was in the chat, doing some screwball stuff in the chat or whatever. Or maybe his brother really did have his phone. I don't know. It's giving My Girlfriend Goes to Another School to me, maybe, but either way, I have fun with these kinds of things. So, Denny, take some time, look into what I said. If I'm wrong about any of it, call back another time when I'm on here. I would be happy to go over it, at another juncture. Truly, I love this more than anything. I have an absolute ball with this kind of thing. But maybe don't have your brother be typing in the chat next time, because it does look, to us, because we can't tell, we didn't know that your brother was with you, if that's really what happened. So it does kind of look like you're just kind of like yapping in the chat, and I'm bearing my soul to you, and you're not listening. So I hope you were being honest on that one, I guess, for my own sanity's sake.
Well, yeah, I don't know. I was not convinced that he was like taking notes or really paying attention in the first place, considering the fact that like you would say, like you pointed out, Stephen Jay Gould, punctuated equilibrium, explained all of that. And then what does he do? Immediately turns around and says, well, Stephen Jay Gould proved this thing wrong. And it's like, no, we just covered that. And then with the stasis, like we talked about the stasis thing, we explained stasis. And then like he comes back in and is like, yeah, but it just seems impossible for them to stay the same if evolution happens.
I know. And I think the reason why I have a lot of patience is one, because I enjoy it a lot, but then also because I'm so good faith brained, even though I've been like shown to be incorrect on that time and time and time and time and time and time and time again, that not everybody is a good faith actor. I hope in my heart of hearts that, he's from Bulgaria. I don't know what the evolution education is like in Bulgaria. Maybe, I don't know, maybe these are totally brand new concepts to him, and it's difficult for him to be like, maybe when you get handed a new concept, you're like, oh, it's stasis here, but does this really count as stasis? I think it's probably more likely that he had a script sitting in front of him from like a creationist answers handbook or whatever, and he's going down the list on that. And because he's just going down the list, it didn't occur to him that the stasis was the same stasis we just talked about, and the Gould is the same Gould that we just talked about. And because it's a script, that's what's being a bugaboo for him. I hope, beyond hopes, that he will re-listen to this conversation and be like, oh shit, I get it. Okay, these were the same things. And that will send him on an academic journey of a lifetime to discover that creationism can't hold any water whatsoever. And then in 5 years, he'll call back and he'll be like, I was that one guy who talked about this, and it gave me the courage to look into it further. And I need that hope right now, John. I'm grasping at straws over here at large. So that's...
No, I understand. I understand. I just... For whatever reason, I hyper focused in on his, on all that, and I guess I didn't have the good faith that you seem to have. Well, I'm glad that you do. That wasn't a knock against you or anything.
No, it's okay. It is a little bit of a knock against me, because even though I'm fighting against it, I have been doing this for so long that I'm less naive than I was. I still, when I encounter someone new, if they haven't proven themselves to me to be a bad faith actor, that I'm usually like, okay, let's benefit of the doubt. Like, maybe it's this, maybe it's that, whatever. But that means that I easily fall victim to people who just kind of want to jerk me around a little bit. They call in, they're not good faith actors. They're sometimes full of shit, and they like to go down a script. And I hope that Denny is not one of those people, but I guess he could be. I don't know. We'll see.
Well, heathens, that's going to be it for today's clip from the line. Again, if you would like to subscribe to the line, their links are in the description. So please go down there and subscribe. And as a reminder, I do host over there at least twice a month on either a Sunday or a Monday. So if you want to see more of me answering questions from callers, please go over to the line and subscribe. Don't forget to stand up and use your voice. Bye, heathens.